Today's presentation is titled Allegro's Airflow journey from on-prem to cloud orchestration at scale. My name is Marek Gawiński, and this is Piotr Dziuba. We are the senior data engineers in Allegro, and we work at the same team. Our daily work concentrates on development and maintaining our big data platform. As a sneak peek, I can reveal that today we will start with what Allegro is, its history, and the scale we reached. Then we will talk about what made that possible, our challenges and applied solutions. We will conclude with an interesting novel approach to keep for ecosystem maintainable with side effects to save quite a lot of money. So let's start from the what Allegro is. Allegro was founded in Poland in 25 years ago. Now operates as a leading online marketplace across Central and Eastern Europe. The Allegro platform connects millions of buyers from across region, as well as European Union with thousands of international merchants who provide millions of products. Currently, Allegro employs approximately 7,000 people. So how we got where we are? The first step was to launch our Hadoop cluster, which began our journey with data collections and processing in mid-2012. So I should mention that as a cluster was expanded, it became one of the largest clusters in Europe. At that time, Crontab, Luigi, and Uzi were used to periodically run processings. Well, using wasn't very user-friendly, so with the introduction of Airflow in the market, 2017, we prepared the options to running dedicated Airflow cluster for teams in our company. Due to demand and the growing number of teams processing data, the number of Airflow as a service instances increased to the total of over 250. To complicate things, in 2022, we initialized the initiative to move big data solutions from our data center to the cloud, which was Google solutions where Airflow as a service had a replacement in the form of Google Cloud Composer service. The lift and shift migration process allowed us to quickly migrate data, solutions, and users to cloud products, but it had its own drawbacks. Concluding the historical overview in 2023 with the completion of migration from our data centers to the cloud, the Hadoop cluster and Airflow instances were removed. Allegro platform is used by over 100 teams with diverse range of roles and competencies. As Conway's law suggests, the structure of an organization is almost always reflected in technical solutions it provides. So a few words about how it's look like in our organization. Google Cloud Composer is a primary tool for scheduling big data workflows in our company. Users' competencies range from pure analytical up to highly specialized engineering. As I mentioned earlier, the lift and shift migration process has created the need to maintain and monitor a large number of environments. We currently have thousands of projects in the Google platform, including dev, test, and prod for logical separations. And as I explained on the previous slide, our organization has a large number of users, multiple composer instances. But what is it used for? Main use cases include data processing, MLOps, governance, utils. During the day, over 50,000 DAGs and over 160,000 tasks are run. Users use over 300 different types of operators in their DAGs. To illustrate that here is shown a very wide span of orchestration services. No surprises, most of processing is based on the BigQuery and Spark, but there are many more other workloads. There is as well. And for more details, insights, how it works behind the scenes, we tell now Piotr.
Okay, thanks, Gavin. Hello, everyone. Okay, so we know where we are and roughly how we get it, but let's ask ourselves, okay, what made it possible to really grow to this point and what keeps it running today? So our ecosystem, as we think about its called data platform, consists of many different elements. Today, I won't be able to run through all of those in very detail, but I would like to highlight a few that actually reflect to this presentation. So first of all is, of course, the DAG authoring. You cannot have processing if you don't have a way to define the DAGs and then make sure they are deployed. Secondly, you need to have a way to provide the needed resources, mainly in the cloud environment, that will allow you to really handle the processing itself and store the results. On top of that is, of course, the governance, which means that for compliance, whether that's law or the company policies, all of those requirements needs to be met, and possibly they should not be that much obstacle for the users. Last but not least is, of course, the support and documentation, if this is supposed to be used by the different users of a wide variety of the competences. So let's dive into the DAG authoring itself. Imagine you are a user that wants to prepare some ETL pipeline. That's the most common use case. You are not left alone. So your first step would be to go to the well-known place, which is the internal developer platform that allows you to create a service template. The service will work as a placeholder for all your code, all your configuration that you can later work with. With the service repository, you can commit your code, make sure the processing and the integration logic kicks in to prepare the working artifact. The artifact itself is stored and waits for you to decide when it's actually a good moment to really make it deployed. No surprise, again, we go to the portal to select whichever version we find at this moment usable, and we make sure it's actually just its destination. Of course, for the managing of the runtimes, you can actually go directly to the UI of the Airflow. There is no problem with it. As a side note, very similar flow works for the cloud resources. Behind the scenes, there is a Terraform and there is a runtime that will run your code the way you defined. To prove that, on the left side, this is the structure of this data product repository. You have all the elements that you may need to use, and of course, you are free to extend it to your needs whenever needed. Of course, the place to place your processings, the documentation, and the source code for any other services that are really used for doing the data preparation. And some structure for defining the infrastructure for the cloud. On the right-hand side, there is a real-world example of a table definition we use. It both provides where to place it and all the governing elements that will make sure it's suitable for the company requirements. Okay, but DAG authoring wouldn't be full without operators. Core provider operation, mainly the Google Cloud provider. They are perfectly fine. There is a great job with those, but they are of general purpose. They are not aware of the structure of our artifacts. They are not aware of the company policies. They are not aware what kind of the compliance they need to meet. So, natural consequence, we introduce some own Allegro Airflow extension, mainly as a set of DAGs and utils that will allow user to kickstart their processing without worrying about all the nitty details. And of course, to make sure they are there, by default, it's pre-installed on any Cloud Composer environment you will provision. Okay. Don't trust me on the word. This is a screenshot from one of those operators, actually the most popular one. This is a proxy for BigQuery insert job operator, and it's intended to run these analytical jobs. At the bottom, you can see how easy it's actually to define only the business-related important details related to the processing task itself. Okay, for the deployment, screenshot from the internal development platform. By the way, it's backed by the Backstage solution, so you may have seen it before. Maybe not in exactly this tab, but as a general rule. You select the environment, you select the version, and the logic behind the scenes takes care of deploying it. What's important, the same artifact can then be promoted to the higher environments. So you kind of write it once, verify, and then make sure you can work with it across different deployments. Okay, so is the story complete? What we have a self-service data platform where it's easy to actually start DAG authoring, where it's easy to get your own environment. And the Airflow becomes the first go-to solution when it comes to defining the processing. Okay, and we combine this with numerous teams with really different expertise. So, can there be any downsides? Yeah, if I'm asking, you are already thinking, we know what happened. So, with over almost 200 instances of the Airflow, numerous DAGs, and many teams, this is a illustration how the DAG distribution looks across the different environments. We have a large environment that will have over almost 500 DAGs. We have a lot of those that are of the medium size, and of course a long tail of the single purpose processing. And don't get me wrong, it wouldn't be anything bad if you have a full business case that actually running on a single processing. But in many cases, this was just a consequences of lift and shift approach. So can we name what are the consequences? Of course, first and obvious is the cost. Every single environment costs, and when you multiply it by 3-digit number, you get even more digits on your bill. But what is not obvious is also bringing some maintenance time. The 4-hour is actually an estimation based from serving our users. How much time do you spend on maintaining monthly? But even though it doesn't sound scary, when you multiply it by 180, you get four people working all the time just for that purpose. So that brings us to the solution. Can we do it better? Manager Composer would be, as the name suggests, a way of providing both worlds together. How to keep current approach that every user, every team has its own separated GCP project where he manages the access and manages the processing happening there. At the same time, having a ready-to-use environment that can orchestrate exactly that environment. So if we would like to decompose it, what would be the moving elements? Of course, the project. We need of course the composer itself. Then comes the permission to really access it, even if it's not your given environment and it's hosted in some external project itself. And of course, which is not obvious, you need also to provide the access to the deployed artifact. This way, the cross-project access will be able to really work. Okay, but there's one missing element between how to provide the cross-section between the composer and the user project. And that's something I will tell more, and it's called service account impersonation. The service account impersonation is a cloud-native mechanism that allows one service account to act as a second one, provided that it has all the required permissions. So what we want to achieve is that on the left side, we have a service account that runs the Airflow. On the right, we have the target user service account, namely the compute user. In the between is the IAM service, and the flow follows. The Airflow scheduler asks for the token, mentioned which user is actually asking for. The IAM service checks whether there is a service account creator role on the given target service account. If yes, it will provide the access token. Nice thing is this is not exactly the same token as if the original user would be asking. It's kind of having both words. It actually combines that, well, the permissions will be applied from the target user. At the same time, it's leaving traces who was the original requester for it, which actually plays quite well with the compliance and checking what was the story behind any given action. To not just trust me on the word, this is example of the IAM configuration to get the permission in place. Not sure if you like it the same as because I find it very simple, yet brilliant in the idea. This is a single point you need to provide as a link. When you revoke this one, basically all the connection for the access is actually taken down. So providing this for any number of projects allows you to actually scale with one environment to any number of user compute projects we need to handle. From the DAG perspective, this is not complicated either. You just need to provide which is the target GCP project the actions will be run, and of course mention the target compute user you want to run it on. Okay, so we have all the moving ingredients, but how it plays with the self-service approach I already mentioned. Of course, it plays well, but you need to have yet another service. For the user perspective, only thing that they need is to bring your own project. And this is a screenshot also from the developer portal where you actually define registration for the MSC service. Behind the scenes, there is a verification whether requesting user is also a member of the GCP project he is asking for. Otherwise, we would be elevating his permissions to interact with not really his project itself. Okay, how it looks in the number. Those are the diagrams showing the adoption of the solution. Top one is showing number of linked projects. They roughly correspond to the number of teams using it, even though it goes beyond 100, which means that there are more than single projects that are linked to the given team. At the same time, it's actually reaching quite a large number, and the bottom one is actually showing real production data. In the middle, you will notice that there is a second instance that needed to be created. And at the moment, they are quite of reaching the same size of almost 1,000 DAGs processed just in the production environment. Okay, well, money tax, yes. So this is a cumulative saving showing how much it would cost if every single of that project would be running its own cloud composer. And after roughly 2 years of operation, we are already plus $1 million on the cloud bill. Not sure if the guy from the Google will really like the approach, but at least it allows us to spend more on different services, and hopefully it's beneficial for both sides. And the second I mentioned, the hidden cost or alternative cost, the maintenance time saved. Even though the 4 FTs doesn't sound that awful, when you kind of accumulate it over a weeks, it actually seems that plenty of time would actually be saved when it comes to, well, delegating of the services to someone else who will handle it. Okay, but is it all bed of roses then? Well, for the shared environment may not be for everyone. So there's no place for special handling. Teams may have their own requirements referring to libraries they use, the versions they want to stick to, and many other different requirements. If you're running a single environment for them, there is no way for customization. And yes, still, DAG maintaining is on the team. We won't help you with the DAG authoring. We provide the tools, we provide the operators, but we won't basically write the DAG for you. But when it comes from the admin perspective, we of course hitting the problem with the noisy neighbors. Basically, everyone sharing the same environment without clear separation of what actually can be done leads to a situation when, well, some of the users are affecting also other processing itself, which also, if you think about it, is also limiting the security in some way, because, well, you're in the environment and you are able to interact almost as anyone. You won't override his DAGs. That's actually handled by the deployment platform, but at the same time, you can actually elevate your rise. We, of course, try to mitigate as much as possible. We look forward for the better separation in the future. But at this moment, well, we kind of accept the risk. And of course, as any shared environment, this is a single point of failure. So we need to make sure it's actually not the most disastrous place we will want to be. Okay, so conclusions. I hope that at this point you already have your own thoughts of it. I will just share mine. They are highly opinionated. So if you ask me, Airflow can be a backbone of a really wide variety of solutions, and we are proof of that. What's more, planning for maintenance from the solution provider perspective is far more important than just providing an easy way to start. But if you go for that, self-service conventions, that's something that's really pays at the long end. And shared environments. Well, they are worth considering if your user base, your use cases plays well with it. But if you ask me, they are definitely not a silver bullet. So thanks for staying with me to this point.